everybody. So today we will have a quiz in the middle towards the end of the first hour, inshallah. Okay, so I want to continue on problem solving for the chapter 24 because we did few examples. Before I proceed, since one of the problems we did at the end of the last session, I'd like to show it to you again because we were going fast. Okay, so this problem, a proton speed as it passes point A has a speed of 2.5 10 to the power 4 meters per second. It follows a trajectory AB through the equipotential surface shown. What is the proton speed at point B? Okay, so here we already have a figure. Okay, so we can. Okay, so this is the velocity at point A. It's 2.5 10 to the power 4. This is the velocity of the proton at point B here. Okay, and we have VB, the potential at is minus 10 volt, and VA is equal to 30 volts. Okay, and we said in a problem like this, so we want to determine the speed. Okay, we can use conservation of energy equation. Remember, conservation of energy says the work done by applied external force is equal delta K plus delta U to gravity plus delta U to the electric field and so on. And in this case, because the charge of or the mass of the proton is so small, the force due to gravitation force is negligible, so usually we ignore this one here. Okay, so in this case we don't have an external applied force. The force is just due to the electric field. So if we take the electric field and the proton as a system, there are no external forces, so this term is also zero. So we end up with delta K plus delta U is equal to 0. Okay, so we can write this. This is K final minus K initial, or 1/2 mv final squared minus K initial, which is 1/2 mv initial squared. Okay, is equal to minus delta U. So this is equal to minus delta U. Okay, and delta U is equal to Q delta V. Yeah? So we can write that this is equal to minus Q delta V, which is the change in potential. Okay, so then we can solve for V final because we have everything. Okay, so we can write 1/2 mv final squared is equal minus Q delta V. Okay, and so V delta V is VB minus VA. Yeah? So this is VB minus VA. Okay, plus 1/2 mv initial squared. Okay, and we can multiply by 2 and divide by m. So this we can get V final is equal to or minus 2 Q divided by m VB minus VA. Okay, and so if we multiply by 2 and divide by m, this comes plus V initial squared, square root of all of this. Okay, so we just use the conservation of energy equation in this case. So the final result, we find that this is equal to 9.1 10 to the power 4 meters per second. Okay, so this is a problem we did last time. So let me start the Kahoot again, and so we can solve more problems. Okay, so please enter the Kahoot. This is also good practice for the quiz. Yeah. V final minus V initial. V final is at point B. V initial at point A. So VB minus VA, the initial position will final position. So V final is final position. V initial is the voltage at the, or the potential at the. So here it's VB minus VA. Yeah? V final position is at B. So it's VB minus VA. Okay? And here the minus sign, I put it inside the parentheses, so it became VA minus VB. Okay, so let's play the Kahoot. Where is the pin? It did not show us the pin, huh? Oh. So please enter the pin, and let's 343 4349, huh? So this is good warm-up for the quiz also. Okay, let me post the first problem while everybody is joining, and solve in teams, huh? Not for the quiz, but this practice is in teams. Okay, so let me start. Okay, so here a point charge Q is equal minus 2.5 microcoulomb is held at rest at the origin. A second point charge Q2 is 4 microcoulomb. It moves from a point at 0.2 meters 0, that is 0.2 on the x-axis and 0 on the y-axis meters, to a point that is 0.15 meters. So 0 the x and 0.15 on the y-axis. How much work is done by an electric force on Q2? So for Q2, in order to move from the initial to the final position, how much work is done by the electric force? Okay, so 2 minutes for this one. 2 minutes. It's better to solve in teams, and this practice, it's better to work in teams. So please, if you can join, because you can benefit from the discussion. It can be teams of 2 or 3, okay? عبد الله ما تقدروا ها؟ نجموا تشتغلوا مع بعض. Join a team, please, and let's solve problems in teams. Ready? Anybody ready? ولا لا? Ready? Okay, here we have ready. يلا يا جماعة, we want you to be ready يعني. Okay. Okay, so choose between A, B, C or D. I will start. So ten seconds. Okay, excellent. 18 correct and 10 incorrect answer. That's very good. It's encouraging. All right, so let's go to this problem. All right, this is a problem, huh? So here, for me, I don't solve any problem without doing a drawing first. I draw first. So I draw, this is my axis, X and Y axis. Q1 is held at the origin, so this is Q1. Okay, this is minus 2.5 microcoulomb. And the second point, charge, is Q2, 4 microcoulombs at 0.20. So it's somewhere here, Q2 at 0.20. Okay, and then we move it. So let me use another color. We move this point to a different location. So we move Q2 to this location, which is 0.15. Okay, so let me call this distance D1, this distance D2. Okay, how much work is done by the electric force? Okay, what do we know about the electric force? We have an equation for the electric force, for the work done by electric force. It is just minus the change in potential energy, minus the change in electric potential energy. Don't forget the minus, because this is the work done by electric force. Okay, so this is minus U final minus U initial, or we can just write it U initial minus U final. Okay, what is U initial? The potential energy of the system of two charges initially is what? K Q1 Q2 divided by the distance. So this is equal to K Q1 Q2 divided by the distance, which is in this case D1. Initially the distance was D1, which is 0.2 meters. Okay, what is U final? U final, now the charge is in a different position, so we get minus K Q1 Q2 divided by the distance D2. Oops, sorry. Divided by the distance D2. So I can take K Q1 Q2 outside. This is 1 over D1 minus 1 over D2. Okay, and you get the result to be 0.15 joules. So 0.15 joules. Clear? Okay, واضح? Is this clear? Okay, next problem. Next. So we have 5910 leading. All right, so here is another problem. Here we have in this figure, two electrons are fixed at the corners A and B of an equilateral triangle of side 2 micrometers. So two electrons separated by 2 micrometers. How much work must be done to bring a third electron to the corner C? So how much work we have to do in order to bring a third electron to point C? And this is an equilateral, it's 2 micrometers. So 2 minutes for this one also. This is very similar to the previous one. So join a team, yeah. Huda, you can join here team, or whoever can join. Yes. نعم. The charge is the charge of an electron. It's minus E. Minus E. Minus 1.610 minus 19. Ready? Ready? Okay, we have here yes, yes. يلا يا جماعة, we want everybody to be on board. See, some are still working. Okay, we have many teams who have finished. Okay, so let me start. Excellent. 22 correct answers and 4 incorrect answers. So we're getting close to perfection here. Okay, so let's go to this problem. All right, so this is the problem. Okay. So initially we have 2 electrons at the corners A and B. Okay, and with a distance of 2 micrometers. How much work must be done by a third electron? Must be done to bring, a third electron to the corner C. So we're bringing it, not, so we're doing external force. Same thing, we write the conservation of energy equation. We say work applied is equal delta K plus delta U electric plus delta U gravitation and so on. Okay. And here we are interested on this work. What is work being applied? What is delta K? 0, because they are initially at rest and they are brought to a resting position. So the velocity, initial and final velocity are 0. So delta K becomes 0, and we obtain work applied is equal to the change in electric potential energy, which is U final minus U initial. So this is the initial position. The final position is when we have an electron. So let me draw it again. So here, this is the final position. So we have an electron here, minus E, and minus E, and the distances are the same. Okay, so we can write work applied is U final. So U final, we have 3 charges. So it's going to be, so let me call this 1, 2, and 3. Okay, so U final, so sorry, you should have 1, 2, and 3. So this is K, Q1, Q2 divided by the distance, okay, plus K, Q1, Q3 divided by the distance, and Q's are minus E in all of these cases. Q is minus E, plus K, Q2, Q3 divided by the distance, okay. What is U initial? U initial, we have only 2 charges. So it's minus K, Q1, Q2 divided by the distance, D. Okay? So since all the charges is minus E, this will cancel with this. Okay? And we obtain 2 K, Q1 times Q2, that's minus E squared, so that's E squared, divided by the distance D. So this is the work applied. Okay, and when you replace the values, you find that this is going to be equal 2.3 10 minus 22 joules. So always remember, work done by the electric field is equal to minus the change, and work done by external applied force is plus. Okay, واضح? Any questions? Clear? Okay, next problem. نعم. How do we know? The wording of the problem will say, it says here, it says how much work must one do. يعني somebody is doing the work, so it's an external work. if it was asking for how much work is done by the electric field or the electric force, then you know it's the electrostatic. So the wording of the problem will tell you. If work has to be done, that means it's an external work. Okay. Next problem. We already have done this one. So next. I don't know, I made a mistake. Skip. Next. Okay, here is another problem. So now we have the electric potential at point on the xy plane is given by V is 2x squared minus 3y squared. In unit vector notation, what is the electric field at a point 3 meters in the x-axis and 2 meters in the y-axis? 2 minutes for this one. This is an easy problem. Remember, the electric field along any direction is minus the derivative of the potential with respect of that direction. It's like Ex is minus the derivative of V with respect of x, partial derivative. Everybody please, يعني لأنه exercising now prepares your brain cells to the quiz. Half a minute left. Okay, ready شباب? Who's ready? They are ready. يلا يا جماعة اليمين. Ready. Okay, so almost we have half are ready almost. So choose between A, B, C or D. I will start the Kahoot. You will have another 20 seconds. Okay, okay, 16 are correct, and we have 13 are incorrect. Okay, let's do this problem. This is should be easier problem than previous ones. Okay, so this is the problem here. An electric potential at point in the xy plane is given by V is 2x squared minus 3y squared. In unit vector notation, what is the electric field at this point? So we know Ex is minus the derivative of partial derivative with respect of x minus. Okay, so let's take the derivative of the V. So we have minus 4x. Okay, that's it. Ey is minus the partial derivative of v with respect of y. So this is going to be minus times minus at a plus 6, so 6y. Okay, so at this point we can write that E is going to be exi, sorry, plus eyj, okay, so this is minus 4xi plus 6yj, okay, and we have x and y, so this is going to be equal minus 12i plus 6 plus 12j. So this is the electric field in volts per meter. So the correct answer is B. Clear? So here we are using the potential in order to calculate the electric field. Next problem. Okay. Alright, so here is another problem. The electric field in a region of space has a component Ey and Ez are equal to 0. Ex is 4 times x. Point A is on the y-axis at y equal 3 meters, and point B is on the x-axis at x equal to 4 meters. What is the potential difference? VB minus VA. VB minus VA. Okay, 2 minutes. Okay, ready? Who's ready? Ready? يلا يا جماعة يلا. Ready? Okay. Ready? Okay, ready. Okay. So, choose between A, B, C or D. Okay, I'll start. Aha. This was a difficult one, apparently. Yeah? So we have 8 correct and we have 21 incorrect. Okay, so this one is challenging. All right, so let's see. Okay, so this is the problem. All right, and I do not solve without drawing. Okay, so let me draw the situation here. Okay, so we have point A at y equals to 3 meters. This is point A. Okay, and we have point B at x equal 4 meters. This is point B. So this is 4, 0, and this is 0, 3. Okay, and we have an electric field. The electric field is 0 in the y and the z direction, and it is equal to 4x in the x direction. And we want to determine VB minus VB. VB minus VA. We have an equation for the potential difference. We can write it's minus the integral of E dotted with ds. Okay, and this is the integral going from A to B. Okay, now this integral I can expand it. If I can expand it, I know E has an x component and y component. E has EX and EXI plus EYJ and so on. So you know that. Okay, so I can write this is actually minus the derivative of EX dx going from XA to XB minus the integral of EY dy going from YA to YB minus the integral of EZ dz going from ZA to ZB. But we know this is 0 and this is 0. So we end up with only the integral minus the integral of EX dx going from XA to XB. So let's put the equation. So this is minus XA is 0 and XB is 4. EX is 4x. EX is 4x dx. So this is simple integral. This we can write x squared 2x squared minus 2x squared evaluated between 0 and 4. So this is minus 2 times 4 squared. So this is so 16 times 2 minus 32. So the correct answer is minus 32 volts. واضح. So we just use the integral, and in this case it simplifies to a simple integral. Okay, we still have time. Can go at least one more problem. Is this clear? Is this problem clear? So we just used the definition and we did the integral. Next. Okay. All right. So let me expand. Let me show this in the real PowerPoint presentation. Okay, so here a graph of the x component of the electric field as a function of x in the region of space is shown. Okay, the scale of the vertical axis EXS is 20 newtons per coulomb. Okay, the y and z components of the electric field are 0. Okay, if the electric potential at the origin at x equal to 0 is 10 volts, what is the electric potential at x equals to 2 meters? What is the electric potential at x equals to 2 meters? 2 minutes for this one. So instead of having equations, you have a graph now. This was in the final exam last year.
دكتور
تفضل.
قسم الكالكوليتر كان ايوز يورز
فما اوريدي فما شكون طلبني فيها، عندي واحده بس، فاذا كان حد عنده
بس تأتي بس
اي برا امشي بسرعه. شوف
مبدأ 22 عندك درس.
اوكي can you be back in 10 minutes؟
بحاول.
اوكي go 10 minutes. شكون طلبني في الكالكوليتر؟ one of the students asked me for calculator. After you find the result, مثلا 69 divided by 2, okay, تعطيك in this, you can press on this like this, so press on it, it will give you in this form, hey, so you can always use this one. With exponential, if you want to do exponential, مثلا 26 exponential minus 3, that's how you use exponential, alright. Okay, ready ولا لا؟ We have ready here. Anybody else ready? Ready there. يلا يا جماعة يلا. This should be easy. Anybody else? Okay, ready here. Ready there. We want as many ready groups as possible. Okay, for the sake of time, let's go. So choose between A 20 volts, B 30 volts, C 40 volts, and D 10 volts. Okay, I'll go to the Kahoot and start it. Okay, so we have 9 correct answers and 19 incorrect answers. Challenging. Okay, so let's look at this solution. Again, I told you this problem was in the final exam. Okay, so we are asked to determine the potential at x equal to 2 meters, and we were given a graph of Ex as a function of x, and the y and the z components of the electric field are 0. Okay, so I can use my previous equation. We have delta V is equal minus E dotted with ds. Since we have only x component, in this case the y and the z components are 0, this becomes minus the integral of Ex dx, going from x initial to x final. So let's take 2 points. Let's do V at 2 meters minus V at 0. So that will be an integral minus the integral from 0 to 2 meters of Ex dx. What's the integral of E between 0 and 2? It's the area under the curve, isn't it? The integral is the area under the curve. So it is this area here. So here I can write this is minus the area between 0 and 2. So minus the area, okay, and what is the area here? Okay, so this is minus the area is, since it's under the x-axis, it's negative area. What's the area? We have the base of the triangle is 2 meters times the height, which is 20, divided by 2. Base times height divided by 2. So 2 times 20, that's 40. 40 divided by 2, that's 20. So that's minus 20. So here we get this is plus 20. So V2 is equal to 20 volts plus V at 0. So that's 20 plus 10, that is 30 volts. So V at 2 is 30 volts. Okay? And I can do the same thing. I can do, for example, the voltage at point 3, V at 3 minus V at 0. Same thing. It's the area under the curve minus the area under the curve. So in this case, if I do the area under the curve, so that's 20 plus, in this case, the base times the height, so 20 plus, that's 30 plus 10, 40. So this is going to be equal here, the area under the curve is, see, what did we say? 30. Okay, so V at 3 meters is going to be 30 plus 10, that's 40 volts. And so on. So I can do it for any point by using this definition. Basically, we are using this definition. And here we are doing the fact that the integral is the area under the curve. You just have to be careful. The area under the curve. If the curve is above the zero axis, it's positive area. If it's under the axis, it's a negative area. Okay? واضح شباب؟ This was in the final exam. Okay. So let's see. Do we have time? Okay, I think we're, let me see if there is any more problems. Next. Yeah, let's do one more problem. Okay, so this is, all right, 2 minutes for this one. Huh? So here, what is the excess charge on a conducting sphere of radius r 0.15 meters if the potential of the sphere is 15,000 volts and V is equal to 0 at infinity? Okay, so we are given a conducting sphere, radius 15.15 meters, and we know the potential at the surface. We want to determine what is the charge. 2 minutes. We're going to start the quiz shortly, huh? Okay, ready? Anybody ready? Ready here, ready there, ready here. This is a one-step problem. Huh? So, choose between A, B, C, or D. I will start the Kahoot. Okay, very good. 20 correct answers and 9 incorrect answers. So this is okay, so this is the problem. So if I draw the sphere, we're given the potential here This is the radius of the sphere, let's say capital R. Okay, remember we did this before and we found that the potential inside the conductor is constant and it's equal to the potential at the surface, and we drew it, actually we drew it, if you draw this axis here like this, if this is the radius R, if this is capital R, we said it's constant inside the conductor, then it goes as KQ over R outside, like a pointed charge. Remember the shell theorem, if we are outside the sphere, we can treat the sphere as if it's a pointed charge located at the center of the sphere. So we know the potential at the surface at R is just equal KQ divided by R. Okay, so I can solve for Q, the charge, it's just equal the potential times R divided by K. Okay, so this is 1500 times the radius, which is 0.15 meters, divided by K. So 10 to the power 9. Okay, so divided by K. And the result is 2.5 10 to the minus 8 coulombs. Okay, so please spread. So go back to social distancing and quiz distancing. So leave at least one space between you and your neighbor. Okay, we will start together. So I'll give you the sheet and keep it face down, please. يلا يا جماعة يلا. Spread. So keep it down until I tell you to start, please. راحت. Please keep it down until I tell you to start. I think 10 minutes. One problem is actually 1 or 2 minutes. Everybody has a quiz? Okay, you can start.